All right, this video is going to walk you through how to find all of the missing parts of a triangle when given the midsegment MP in this example here. Now we're also working with a right triangle, so we might be able to incorporate some Pythagorean theorem and sine, cosine, and tangent features to help us find missing pieces as well. Let's get started. When we talk about midsegments like we have here in MP, it is always going to be half the distance of the other side length that you see here. So I know that the length of MP, since I have 100 on the longer side that it's parallel with, this side length has to be 50. So add 50 to your answer blank down below, if that's the case of your problem. Whatever the half of your measure is from this side to this side. Next, MC. MC is this distance from here to here. We also know that for M as your midpoint, it cuts the segment AC in half. We call that a segment bisector. So that means if this is 14, then MC has to also be 14. So put a 14 down here in this paper, and then also here on the actual blanks. AC. Well, AC is pretty obvious. It's the length of the whole segment. So if I have 14 and 14, that total length is going to add up to 28. So add that to your lengths as well. Now let's try to focus on the bottom part of this triangle. We have a triangle that happens to be a right triangle. So if you know that the whole length of this long side here is 28 and the hypotenuse is 100, to find the missing third side, let's think about Pythagorean theorem. So let's set it up over here. There we have 28 for one leg, hypotenuse of 100. To find this missing side, we'll call it side B. When we talk about a squared plus b squared equals c squared, filling in those numbers where 28 is your a squared and 100 is your hypotenuse c squared, we'll solve this for b. In this case here, if you take 28 squared, you get 784. Take your 100 squared and you get 10,000. When you subtract 784 over to the other side and then square root, you get an answer for CB, the length of CB, to be 96, or your missing side is 96 units long. So go over to your picture, write in 96 from the distance across from C all the way over to B, 96. Then from there, we know that P is the midpoint, which means it cuts 96 into two equal pieces. So therefore, I'll have 48 for CP and 48 for PB. Fill in those three measures now for your answer blank as well. Whatever you have, once you've calculated your third side of your right triangle, chop it in half for your two missing sides there. Lastly, let's talk about angles. We know in right triangles you can incorporate sine, cosine, and tangent. Let's focus in on just what we started with earlier. We had 28 for this length right here, and we had a length of 100. Let's draw that down over here. Now, if I'm trying to find angle 6, for example, the 28 would be considered opposite that angle, and 100 is directly across from your box, so therefore that's your hypotenuse. And in the word SOHCAHTOA, the only one that deals with opposite and hypotenuse is the word sine, or the so part that you see here. So sine is equal to opposite over hypotenuse. But now when you're trying to find angles, remember this also, you have to press second sine on your calculator, or the inverse sine of 28 divided by 100. So do that next, and the answer comes out to be 16.26. Now the directions do talk about rounding your answer to the nearest integer. So in this case right here, your nearest integer would be then 16 degrees. So now on your screen, write down, or on your paper, sorry, write down the measure of angle 6, that's going to be 16 degrees. I'll do the same. Now if angle 6 is 16 degrees, I can also know that angle 4 and 6 are what we call corresponding angles, because midsegments are always parallel with the side that they're across from. In this case here, they're across from the 100. So if this is parallel, this means these 6 and 4 are corresponding, which then would tell you that angle 4 is also 16 degrees. So on your screen down below, as you're filling in your blanks, whatever you got for angle 6, that will also match your same measure for angle 4. So I've done that as well. There's my 16 that I figured out from the inverse sine of 28 over 100, and then 4 is corresponding. Now what you have to also understand about 4 is it's next to 5. That they form a linear pair. A straight line has 180 degrees. So if I'm using up 16 degrees here, that would then mean I have 164 degrees left over for this angle 5. If you just take 180 degrees minus 16, you'll get 164. I'll write that on the screen here too. This angle 5 is 164 degrees as you measure out this angle right there. Then if you've got 164 for that angle, then you got to try to find out what is the measure of angle 1 or angle 3. Let's focus on the big triangle. I've got 16 degrees here, I've got 90 degrees here, and then angle 1. Let's draw a picture of what that looks like down here. I've got 16, 90, and I'm trying to find angle 1. Now if angle 1 is this angle right here, I would just take simply 180 degrees minus 90 minus 16, and the answer comes out to be 74 degrees. So angle 1 is going to be 74 degrees. Fill that in on your screen as well. Now if angle 1 is 74 degrees, I see I have angle 3 is corresponding also. That's 74 degrees also. Corresponding angles when lines are parallel are always equal. And then we have to ask ourselves, well, angle 2 and angle 3, those two angles form a linear pair also. So I have 74 degrees here, I would have to have 106 degrees left over for angle 2. So that means on your sheet screen then you've got 106 for angle 2. Now I believe I've talked through every one of your angles. So as you look at this problem, remember, mid-segments are half the length of what you have for your side that's opposite, and they're also going to be also parallel, creating all these parallel line relationships that you see in the picture as well. Don't forget 180 degrees in a triangle, and also that you have SOHCAHTOA options to find missing pieces as well. Hopefully this video helps, and good luck on your question.